Hi, I'm Danae Beckford from grade 937, and in this video I'll be discussing a type of camera and how exactly it relates to the human eye. So the type of camera I'll be looking at in today's video is the pinhole camera. So first thing first, let's look at the objectives of today's video. So objective number one is that I'll be showing a picture of the pinhole camera that I created. Number two, I'll be showing a video of me demonstrating how the pinhole camera that I created works. Number three, I'll be looking at what is a pinhole camera exactly. Number four, what is the eye. Number five, I'll be listing some similarities between the camera and the eye. And then finally, number six, I'll be explaining these similarities, so going more in depth with them. So let's jump into it. Objective number one. So right here is a picture showing the different angles of the pinhole camera I created. I used a shoebox, a tissue roll, black construction papers, white paper on which I applied oil later to make it translucent, an old book cover, glue, and tape. So now I'll be showing the video of me demonstrating how exactly the camera works. Objective number two. Hi, right now I'll be demonstrating how my pinhole camera works using this lit candle. So the first step was to light the candle, which is already done. So now I'll be just turning my pinhole camera to the back part, which is the part with the translucent paper, and the part that is opposite to the part with the pinhole. So the back part. The image that we're expecting to see right now is an upside down image or an inverted image of the candle flame. So let's look. So right there we can see our image. It's an upside down candle flame. Now I'll be demonstrating something else. So I'm going to open my curtain a little bit to let a little light in and see how the image changes. So as you can see, the image is blurry and it's unfocused. Now I'll be closing it and the image is sharper, less blurry, and more focused. So that's how a pinhole camera works. It shows an upside down image, and the more light that is let in, the more blurry the image becomes. Objective number three. So now that we've seen the camera and how it works, let's move on to objective number three. What is a pinhole camera? Well, a pinhole camera is one of the simplest kind of cameras. It just makes use of a tiny opening, a pinhole size opening as the name suggests, to focus all light rays within the smallest possible area to obtain an image as clearly as possible. The simple image formed using a pinhole camera is always inverted. What this means is that the image is always upside down. So now here's a picture to help you visualize what I was saying. So as you can see, there's a hole in the front of the box that's focusing the light rays and projecting it onto the screen at the back of the box to show an upside down image or an inverted image of the balloon. Objective number four. What is the eye? Well, this is basic knowledge that many people already know, if not everyone. The human eye is an organ that detects light and sends signals along the optic nerve to the brain. Perhaps it's one of the most complex organs of the body. The eye is made up of several parts, and each individual part contributes to our abilities as humans to see images. So now we know what the eye is and what the pinhole camera is. What are the similarities between these two? Like, what could these two possibly have in common? Objective number five. Now, the first similarity is, as could be seen in the definitions, is that both have an image formed by detecting light rays and focusing them. Similarity number two is both create upside down images. Similarity number three, if a lot of light is let in, the image will be brighter. And the fourth and final similarity is that each has a hole in the front and a detector at the back. So let's look at these in depth now. Objective number six. Starting from number one. So similarity number one was that both have an image formed by detecting light rays and focusing them, which could have been seen in the definitions. So this one is pretty self-explanatory. They both detect light rays and focus them from an object to form images that we as humans see. Similarity number two is that both create upside down images. Well, light passes through both the pinhole camera and the human eye to project an upside down image. In a pinhole camera, the light passes through the pinhole to project the image onto the back of the box, and in the human eye, light passes through the lens to project an upside down image on the back of the retina. The brain then flips the image so that we experience it right side up. So that's the only reason why we don't see images inverted like the pinhole camera. It's because the brain flips the image. So similarity number 3 now. If a lot of light is let in, the image will be brighter. Using a larger pinhole or being in a very bright environment gives you a brighter image, since it lets in more light and increases the overlapping of the image. This results in the image being blurry, losing its sharpness, and being unfocused. So we usually use a smaller hole in the pinhole camera, which will make the image be more sharp and more focused. So just like the pinhole camera now, our eyes cannot focus by adjusting the shape of its lens. So when there's so much light being let into the eye, the image will become blurry and unfocused. So this is why we tend to squint our eyes in very bright environment, if you notice, to let less light in so that an image appear more focused. Now the fourth and final similarity. They each has a hole in the front and a detector at the back. So this is very much evident on the pinhole camera, as could be seen in the image I showed earlier, with the pinhole in the front and then the translucent paper, which would be the projector at the back. And for the eye, the pupil would be the small hole at the front, and the retina is the projector at the back. So that's the fourth. That was the sixth and final objective being completed. So that's the end of this video. I hope. Thank you for watching.